Hello, and welcome to 5-Minute Math. Today we are looking at some teaching activities to use with Texas Standard 8.5i. That is writing an equation in the slope-intercept form, y equals mx plus b. So this is a blog post off my website. I will include the link to this post in the video description. We start off at the top of the blog post with some basic teaching videos. So how we can identify the slope-intercept form in problems, how we can identify the slope-intercept form in tables, and then in graphs. So those are just some basic teaching videos. The reason that I'm writing this blog post and making this video is because students across the state of Texas struggled with this recently on a STAR test. On the 2023 STAR test, only 36% of eighth graders across the state were able to get this correct. This particular item is number 20. Students were given 2 different points, and it's not even a new item type. They just had to multiple choice it. They had to identify using the point slope form what is the correct slope intercept form here of this particular problem. There's a video showing how to find the correct answer. And then we had 30% of our students get full credit on number 30, 33 get partial credit. Same type deal. It's another graph. They don't give you the points, but you can at least infer them. You've got some clear points right there at 0, 6, right, and negative 4, 0, but it is a drag and drop, so only 33% of the students were able to find the correct slope and the correct y-intercept. And so there's the video for that one as well. Now, all of the activities on this particular blog post are going to follow this teaching philosophy of active, playful learning. If you want to learn more about it, you can click on it here. But basically, math should be fun. It should be joyful, meaningful, engaging, active. And when that happens, students are more engaged and are more willing to learn, and they remember a lot more. So there's a lot more information about that if you want to read more about it. But this particular video is going to live right here underneath this walkthrough sentence right here. And let's start with our activities. There's 5 of them here. The first one is called Real World Scenario Race. So what we're wanting to do is put students in pairs. We want to give each pair a copy of the real world scenarios. I've got that linked, and it's right here. This is from STAR test items, and I just copied out, obviously not the ABCD, but I just copied out the actual text of the verbal description, and I put those 6 right there. And what they're wanting to do is within a short time limit. So make it short. You will have to decide how long. There's 6 items, so maybe 90 seconds, maybe 120 seconds, maybe just 60 seconds. All you're wanting to do is to give them a short amount of time, enough to where they're most likely not going to be able to get all of them correct on the first pass through. After you have that time limit elapse, you quickly share the correct answers, have students score their papers. You can talk about strategies as a class if you want to, and then you give them a new set of problems. And what I did here is there's similar examples linked right down here. It's another 6, just like the first 6. And they're just trying to beat their previous scores. So they're really competing against themselves with a partner, not necessarily against others. So some variations. You can adjust the time limit based on the skill level of your students. Each group can have their own time limit if you want to. They can use their phones to set varying time limits. Really, you can endlessly recreate this activity. All I did was I took the text here. I would copy this, go into ChatGPT and say, create a problem like this. And then I would, paste that text in there, and ChatGPT gave me another problem like that. So you can endlessly repeat this. And you can make this a weekly task and have your group score over time, graph their progress, and see if they get quicker and quicker. Because identifying slope-intercept form from a verbal description can sometimes be difficult for students. That's our first activity. Second activity is just called linear identification. All we want to do is identify the basic parts of the linear equation, create a table of values, and graph it. You are going to need some sticky notes. So what you want to do is you want to pair students up again. You want to give each pair a linear equation to work with. So I've got this right here. And so here's the basic first problem right here. So I've got this y equals 2x plus 3. And so what we're going to ask them to do here is we want them to identify the slope and the y-intercept. And it's obvious right here. Obviously, our slope is 2, our y-intercept is 3. But just because it's obvious to us doesn't mean it's obvious to the students. We want to give them short, easy wins. We want them to be able to quickly identify the 2 and the 3 as the slope and the y-intercept respectively. And then we want them to, using that equation, generate a table of values and graph the coordinates. So let's create some x and y coordinates, and then let's go ahead and graph it right here. So students have a nice representation of table of values and a graph of this y equals 2x plus 3. Now what we do here is we're going to use the sticky note, and we're going to cover up the left side of the paper. So that left side of the paper is going to be all of this right here, the slope, the intercept, the table of values, and all of that. And what we want to do is the new pair is going to, just from the graph, going to identify a table of values and the slope and the intercept and an equation. So they're basically going to reverse engineer the table of values and the slope intercept form just from the graph. And that would be our linear identification here. So what we can do to have some variations here, because it's just an identification activity, is you can have an alternate version, right? So here's the alternate version. I've got that linked right here. And you notice that instead of the slope-intercept form, you notice that I've actually given you the slope and the y-intercept. Students would have to create the linear equation, the y equals mx plus b. So that's just, it's the exact same as what I've got right here. I took the exact same ones, but I just, instead of giving you the full equation, I give you the slope and the y-intercept. But that would just be a slight alternate to see if they can build that equation. If students are having some difficulties identifying the slope and the y-intercept from just the graph, right, because the sticky note is placed right here, and they're supposed to identify everything from just the graph, what you can do is you can have students only have the sticky note cover this top part right here, leaving the table of values open so they can identify the slope and the y-intercept from either the table of values or from the graph. And then if you really want to, there is a blank space in the bottom left-hand corner. Students can create a verbal description, a real-world scenario that incorporates that slope and that y-intercept so they can add something to it. But that's all we're trying to do here is get kids to recognize that linear equations can look like graphs, they can look like table of values, they can look like equations, or even possibly verbal descriptions. All right, so our next activity is called table race. We're really obviously just working with tables here. So we want to put students into groups of 3. So we either going to display or print out 10 tables and then 10 matching equations in random order. So I've got a sample set here, but uh, I went ahead and put the correct equation underneath. What we would do here, if you wanted to, is if you wanted to use these, is you would need to take these actual equations, right? And you would want to print those out separately, and you would want to just put the tables out there. You might want to cut them up. You might want to just have one sheet per paper. But for your ease, this is the answer key. So the correct equations are listed underneath that. But what you're wanting students to do is you're wanting them to have 10 tables and then 10 matching equations. They need to be in random order. So obviously I put them here in the correct order. So you need to randomize this. It's a Google Doc, so you could just make your own copy. And then all they're trying to do is match which group can match the 10 tables with the 10 correct equations first. And then you want to ask students to share the strategies for finding the matching equations because students are going to use different equations. If they just have the tables here, they're going to use different strategies to find the correct equations. And so, pretty simple activity. What you might want to do as a variation is first start with just 5 tables and equations, have them match those, have the class share the strategies, right? One thing I always do is look to see if there's either a 0 or a 1, because if I can land on a 0 or 1, like look at this right here, I'm definitely going to use that because that's going to be a lot easier to subtract with. Here's another example right here. You're looking for zeros and ones if they exist. Then have them do the other 5 and see if the new strategies might help. Now, another variation here is to raise the difficulty, withhold the equations. Just give them the tables first. Then after a few moments, maybe 2 minutes, 3 minutes, give them the equation. So have them try to generate their own equations from the tables before you actually give them the equations. And then another opportunity here would be to change all the x values so they're identical, like 1, 2, or 3. Now, obviously, you're going to have to change some of the y values here to match, but if all the x values are identical, that's just going to make it look a lot different. So that's that activity. We've got a graphing activity called match the graph, right? So we're going to use an online graphing tool, most likely Desmos, but you can use something else if you want to. And what you want to do is you want to give student pairs, right? You're going to pair them up, a verbal description of a linear problem. So let's look at our examples here. So our examples is going to be this match the graph right here. And underneath each problem are 3 clues to use to create the graph. So this is an example, and then I left this graph in here, and this is an image from Desmos here. So this is actually from the STAR test. The company is drilling a water well. The graph models the linear relationship between the depth of the well and the time spent drilling. And this is a Desmos recreation of the actual graph that's there. Now, what I put this delete graph in here because you would want to leave that blank, but I wanted to leave the first one as an exemplar. The way you want to make it look is the domain, right? So the x-axis has, a range from 0 to 6. The range, the y-axis has from 0 to 55, and there are different steps or scale factors here. And we've got domain and range label, and we've got all of this down here. Now, how students are going to build this is the linear function passes through 1, 6, and 3, 18. And the linear function is proportional, which means it's going to pass through the origin. So the linear function has a slope of 6. So these are 3 different clues. So if I wanted to, right, I can delete all this. And as a student, I would need to build the correct graph with just these 3 clues. So let me show you what the full answer looks like. So this is actually from the STAR test. So you see we have a matching graph right there. And so here are some other examples. So this is from the 2019 STAR. And so students would get this, or the groups would get this, and you would have to get into Desmos and you would have to set the domain and the range, right? So let me show you what that looks like here. So what we're going to do is we would, use this settings right here. And the domain here is going to be from 0 to 450. So my x-axis, we're going to switch it from 0 to 450. Step is going to be 100. And the label here, it says, is going to be number of miles traveled. Number of miles traveled. And then we do the same thing with our range. It's going to be 0 to 300 with a step of 30. And then we have a label there of number of gallons of fuel remaining. All right, so now that we have this, so you see that I've got let's make that full screen. So here's my x-axis, and there's my y-axis. Okay, so I've got the labels, I've got that ready. Now, I need to actually graph this function. How do I do that? Here are my clues. The linear function passes through these 2 points. All right, so if I want to, I can work that out. It also has a y-intercept of 240, and it has a slope of negative 1/10. Okay, so if I wanted to, with that, I can easily get that negative 0.1 and then plus 240. Okay, all right, and then so there's my graph right there. Let's put an X in there so it actually works. So there's my graph, and I'm probably going to have to zoom out there to at least get the full thing right there. All right, so there's my graph. Now, how does this actually look? Yep, see, there it is right there. All right, so I changed it. If I wanted to go back, I can change my X and Y axis to make it look like that. So that's how this one would actually work. Is students are actually building a graph from these clues. They're trying to get the domain and the range, and they're trying to get it to match this one right there. So what they could do is they can build that graph. They can match it by actually referencing the visual on the release item. Now, here are some variations. One thing we can do, right, is instead of giving all of them the clues, because Once I had this clue right here, it's proportional as a linear slope of 5. I know that it's going to have no y-intercept, right? It's going to be a plus 0, and it's going to have a slope of 5. One thing is just to delete these two clues. Just give students the 2 points. Have them figure out the slope, right? And then have them plug those points back in, one of those points back in to find the y-intercept. So that's definitely going to ratchet up the difficulties, taking those last two clues off. If you want, right, you can create the graph and you can insert it, have pairs find another pair that created the graph for a different problem, and then they can swap problems and solve. So they can do a little swapping as long as they didn't find the exact same graph. They can access, if the internet access is difficult or just too time consuming, you can do all this graph paper. And then after students have completed all 3 examples, because there are 3 examples included here, right? There's there's this one, and then there's the exemplar here, and just feel free to delete all that. You can actually have them create one of their own. All right, our final activity is called graphing time. So we're going to also use another online graphing tool. We're going to open up Desmos. Now, you're going to give students clues to describe the linear equation that you'd like for them to graph. So you might say it has a slope of -2, passes through the origin. It has a slope of 1/2, has a y-intercept of -3. Students are simply going to write an equation to match the clues and graph the function. That's it. Super simple, but you want them to be able to create an equation, right, for this. So this first one would be y equals -2x. The second one would be y equals 1/2 or 0.5x minus 3. Then you go over the correct answer for the class. Super simple. It doesn't have to be rocket science, but you want these kids to be able to take those clues and immediately put a slope into the m, put a y-intercept into the b, and then graph it. After students have participated multiple times, you can allow them to graph a linear equation of their choice, and then they come up to the front of the class and give clues so that everyone else can, graph that same equation. Instead of giving them the slope, this is how we make it a little bit more difficult. Give them proportions that are equivalent to the unit rate, such as the line rises 5 units as it moves 2 units to the right, so then your slope would be 2.5, but have them make that conversion. And then you can display a graph linear function. Just display the function itself, the graph, and have them match it on their Chromebook. So they're going to have to either visually match it, find 2 points, or they can see if they can match their equation with yours. So those are all activities that we can use to teach TEKS 8.5i.